So my title is, When is Arctic Change Bad? And illustrated here with a cushion pink plant, also called the compass plant, where the flowers are on the warm side of this little plant. And we'll talk about the changing Arctic. And I begin with this article, Welcome to the Fastest Heating Place on Earth, some years ago. Very nice article. And the narrative is about the warming and, of course, all the changes associated with it. I meet many journalists, and they always frame it either as something negative, and then there is a school that wants to talk about the opportunities, all the resources we will be able to reach, all the fish we will catch, and all the goods we will transport across the Arctic. And I suppose in these days that narrative might get more attention than, but for the most part, they want to talk about the negative. So we are indeed in the warmest, fastest changing place. And you can have these kinds of maps. So the top panel shows the long time change, and the reddest spot indeed is Svalbard. And we can then proudly say that this is the place to go to see climate change. I think we will have competition. There are 2 flights a week this summer to Greenland from New York, 4 hours from New York. And the President of the United States certainly has put a lot of attention on Greenland. So I expect we won't see as many journalists here the coming year. Meanwhile, temperature is going up. We have these types of records here from Svalbard. And this is outside Neolus. The gentleman there is taller than I, and this glacier is melting twice his height per year at this point. And we can talk about temperature on Svalbard. The winters warm more than the summer, at least until a few years ago. The winter warming is approaching 10 degrees across the course of the last 30 years. And the Arctic as a whole warms 3 to 4 times faster than the global average. And finally, Svalbard warms fastest in the Arctic. And we can have pictures like these, where the arrows point to the same mountain, and you can look to the left, to the right, or in front, or in back, and you see obvious change. And the narrative is, this is bad. And maybe it is. There are many other changes. Here, an example in the Barents Sea, habitat loss due to climate change is large, and the reddish area here shows values of 100 or above days, fewer days with ice in this region of the Earth. So, and of course, ice-dependent species are severely affected by that. This is a British guillemot, and they live on bird cliffs, and we see large numbers on the bird cliffs. But we also see a decline in the population of these birds throughout Svalbard. The decline, you can have a narrative. It's the ocean around Svalbard that is the problem. They are Our data show that they're reproducing as normal. There are a lot of chicks, but they don't survive the winter. So much of this signal is probably related to winter habitat rather than what is here, right here in Svalbard. But the plot thickens. This is an old article, but it shows energy flows. And if you go back to the 16th century, the sun was shining up on top, energy coming in, and then it propagates through the food chain. And down here are some nice whales, bowhead whales. Now, in 1596, Wilhelm Barents discovered Svalbard. And since then, humankind has killed quite a few whales. And of course, if you eliminate the whale, something happens with the food chain. And this article suggests that more energy will go to the birds. So maybe the bird cliff that we see now with a lot of birds on it is due to a perturbation that started many hundred years ago and little to do with climate. So are the changes bad? Well, AMAP and others produce maps like this, and there are dozens of these types of maps. And this is, a particular one is ground temperature, and it shows then how permafrost will change according to these models. This is a wolf, a formidable animal, extremely diverse. The original distribution of the gray wolf is like so, from the deserts of Saudi Arabia to the northern tip of Greenland. There are wolves quite close to us here, just across the water in Greenland. The red are areas where there used to be wolves, but humankind has not liked wolves. It has nothing to do with climate change. But my point is, the wolf can live on northern Greenland, the wolf can live in southern India. This is a narwhal. Narwhals are very special in that they only live on the ice edge. And any change in the ice edge will alter their ability to live on the planet. So is this good or bad? Is this large or small? For the wolf, it means very little. For the narwhal, the changes like this can be quite dramatic. But it gets even worse. It's not only climate. If you look at the planet from space, it looks like it used to. But if you go down on the ground, we see a lot of change. And this is from Africa. And humanity has become a dominant force in many ways. This is from Norway. And we see a house there. This is the house in 1969. And it has changed quite dramatically. You might get a glimpse of it here. This has little to do with climate change. There is some climate change, of course, but it's mainly because we don't have sheep and goats in this place anymore. Humankind makes many changes. And if we look at the vertebra population, not the number of species, but the population, they have declined by 73% since 1970. And the causes of that are climate, pollution, invasive species, overexploitation, land use, and habitat loss. I place these in front of you in order, but the narrative out there is not the one it really is. Climate has thus far not killed very many animals, but certainly many of the other things we are doing have large effects. So now we shall discuss change. This is an old article from 1922 in the Monthly Weather Review. And down here, there is, let's see, I need the pointer. Down here, it says the changing Arctic. And for those of you with bad eyesight like myself, we can blow that up. And it says the changing Arctic. The Arctic seems to be warming up. Reports from fishermen, seal hunters, and explorers who sail the seas about Spitsbergen and the Eastern Arctic all point to a radical change in climatic conditions and a hitherto unheard of high temperatures in that part of the Earth's surface. Could be from any tabloid paper also today. The point being, there has been change, will always be change. And in fact, if we open the stage and look at the time history of the planet, this spiral begins at 4.5 billion years, and there are all sorts of events. Nothing much happened for the first 2 billion years life-wise, but the fan that opens up is quite dramatic. We have then at the top some dinosaurs, for example. And the past 2 million years, maybe human beings. Change. There is nothing in this picture that indicates status quo. There is nothing in this picture that says change is not coming. And in fact, when we discuss sustainability and where the planet is going, we have to have this perspective. And we have to have this perspective also in our science. The dinosaur it was not sustainable to be a dinosaur. And there is no baseline. We discuss change, we measure and measure, but we're measuring towards a backdrop where everything is changing all the time. Then we have to relate to change. Humans have a remarkable capacity to adapt. Tolerances in this room might differ, but everyone has a limit. How much can we stand? There is also something in us that if nothing happens, we get bored. And yesterday in the workshop, some people commented that the workshop was boring. If too much happens, we get confused and afraid and bewildered. So healthy levels of change can certainly stimulate personal growth and generate feelings of accomplishment, but imposed change can often exceed healthy limits of change. I think what we are doing to the planet is certainly a lot of imposed change that exceeds our capacities. Human capacity sets limits. Human capacity for healthy change. And when we discuss adaptation, changing to green technology or whatever, we have to discuss the complexity of the solutions and the amount of information that we can digest. We are drowning in information. We are drowning in data. How do we find the good data? How do we find the good information? So we must not forget the human beings, which we tend to do when we discuss finding the exact number. I've said many times, also in the article we started out with, we don't need another decimal. We know enough. Sometimes we certainly should be doing good science, but we also have to have perspectives on the science we do. So there is a QR code, and we're supposed to write things about Svalbard in the future. And society asks of us to say something about Svalbard in the future. And I was playing with the thought of having these questions on the workshop, but I've tried to do it myself. Somebody argued it was too complicated. Wilhelm Barents discovered Svalbard 429 years ago. There is an entry in the Icelandic sagas that there maybe was a sighting of Svalbard, but we don't know. IPCC scenarios are often for 2100, 75 years into the future. What is needed to describe the Svalbard environment 75 years in the future? What is needed to describe the Svalbard's environment 429 years from now? Just think about it for a while. And we can, I don't have time, but how well can we actually characterize the environment 75 years ago or 429 years ago? So if we visit uncertainties 75 years in the future, certainly the human beings are a big source. What do we emit? What do we pollute? What policies do we live with? And how much does Longyearbyen want to grow or can grow? And of course, geopolitical stability. Climate and Arctic amplification, ocean currents, moisture transport, feedbacks, glacial and permafrost dynamics, ecosystem changes, both adaptation, migration, exploitation. There are a lot of fishing boats out there, but we never discuss how much energy they are extracting from the ecosystems. All of this is going on. I went through, I've been looking at these CES reports, and much of this are things that are studied within science. And if you step up to 429 years in the future, there are all sorts of uncertainties, and the human uncertainties become even deeper. How many countries were there that exist today 429 years ago? Not very many. Japan, China, Russia, France, Spain, England. Portugal was sort of in union with Spain. Sweden, the Ottoman Empire, and Ethiopia. And that finishes the list. Probably the future is quite different. Geoengineering is already being discussed in IPCC as part of our future. There are unpredictable regional effects for sure. Resource use patterns will change. Lithium was not very important 50 years ago. And climate Arctic amplification, we will have irreversible warming, we will have runaway feedbacks, Atlantic meridional overturning. Of course, large-scale differences also in ecosystems, loss of ice-dependent ecosystems and extinctions. And even geological processes have to be looked at on this time scale. Isostatic rebound, volcanic eruptions, and earthquakes. Global feedbacks, forest collapse elsewhere, ocean acidification, and many others. And all of it comes together. We have data limitations and modeling challenges. And as a mathematician, we ask, how many walruses are there out there? And we struggle with that. Yet society is asking, how is the number of walruses changing? And society is even crueler. They ask, what is the rate of change? How is the rate of change changing? The second derivative. We don't even know how many there are, and then we're supposed to quantify the second derivative. We struggle with that. And it's not only time derivatives. How many guillemots per whale lost? The partial derivative is difficult to get at. To address these uncertainties, we have to, in order to improve predictions and mitigation impacts on Svalbard environment, requires comprehensive interdisciplinary research, enhanced monitoring systems and models, and international collaboration, which I see in this room, and we call it SIOS. But Svalbard is also connected to the Arctic and the globe, and we should be feeding into things like ICARP4 and the next polar year, which some people in the room already claim we are doing. Keep up the good work. And I am running out of time, so we will spend time on the end. And how many walruses? The beautiful song of the walrus is losing its habitat, and we must continue to count the walruses and also predict how they will react as the system changes. We have a lot of work to do together. Thank you all.